Scholenberg Global Universitätes presents. Operation and Preventive Maintenance of Central Air Conditioning Plants. Author: Arvind Avan. The information contained in this course has been obtained from very reliable sources, extracts from the internet and personal experiences of the author. This course has been designed to facilitate easy understanding of the operation and preventive maintenance of central AC plants, through audio, comical images and imaginative animations which are the creations of Scholenberg. The author disclaims all warranties to the accuracy, completeness, or adequacy of such information. The author shall have no liability for errors, omissions, inadequacies in the information contained herein and interpretations thereof. The author, and all those who assisted in preparing this tutorial, shall not be responsible for loss of any kind, whatsoever, sustained by any person who relies on this material. Every effort has been made to trace the owners of the copyright material included in this presentation. The author would be grateful for any omissions brought to his notice for acknowledgements in future editions. The material and communication methodology in this presentation is copyrighted. No parts of this presentation may be reproduced, stored, or distributed in any form or by any means either on paper or electronic media, unless authorized by the author. About the author. The author, Arvind Avan, is a mechanical engineer with specialization in air conditioning with over 45 years experience in air conditioning and utility domain. He is a subject matter expert and certified lead trainer, Level 6 with Electronics Sector Skills Council of India, ESSCI, under the Ministry of Skill Development and Entrepreneurship Government of India, and a visiting faculty with ISHRI. He has contributed to the following. 1. Handbook for Technicians, Air Conditioning and Refrigeration by ISHRI. 2. Multi-Skill Technician Handbook by CARE, Voltas. 3. Trainers PPT, FTAC for ESSCI. 4. App Contents FTAC for ESSCI. 5. Revamping and refurbishments of the course materials for ISHRI. 6. Multimedia contents in HVAC and home appliances. These are available online from Scholenberg International Private Limited. The link is https://sbgblv.com. This is the animation of an air-cooled, packaged air conditioning plant. This is the animation of a water-cooled, packaged air conditioning plant. This is the animation of an air-cooled, packaged chiller AC plant. This is the animation of a water-cooled, packaged chiller AC plant. This is the equipment layout of a water-cooled chiller, in the AC plant room. Pre-checks before startup of an central AC plant. Serial number. Checks. 1. Ensure that all the condenser water circuit valves are open. 2. Ensure that all the chilled water circuit valves are open. 3. Ensure that all the refrigerant circuit valves are open. 4. Ensure that there is sufficient water in the cooling tower. 5. Ensure that there is sufficient water in the expansion tank. 6. Ensure that the plant room ventilation fans are on. 7. Check the mains voltage. It should be between 400 to 440 volts. 8. Ensure that the compressor crankcase is warm before starting the compressor. 9. Ensure that the handheld firefighting equipments are available, and in good condition. Operating procedure of a water-cooled chiller. Steps. 1. Switch on the main switch, located on the main electrical panel. The power indication lights will come on. The crankcase heater will come on. 2. Let the crankcase to warm up. 3. Switch on the condenser water pump CDWP. 4. Switch on the cooling tower fans. 5. Switch on the chiller water pump CHWP. 6. Switch on the compressor. The crankcase heater will switch off automatically. 7. When the return water temperature of the chiller has reached 6 degrees centigrade, go to the AHU which is located near the AC space, and switch it on. Pumps, checklist. 1. Clean pump strainers. 2. Minimize water leakage through pump glands and valves. 3. Ensure pump and motor bearings are greased. 4. Check pump alignment couplings and foundation bolts. 5. Check starter operation. 6. Check pump operation for noise and vibration. 7. Ensure check valve is holding. 8. Check whether or not gate valves are holding. Once in 6 months. Cooling towers, checklist. 1. Clean cooling tower sump. 2. Clean cooling tower strainer. 3. Clean float operation. 4. Clean clogged nozzle/sprinkler holes where applicable. 5. Check sprinkler RPM. 6. Ensure honeycomb is not clogged. 7. Check fan operation. 8. Check starter operation. 9. Ensure tightness of electrical connections at starter and motor. 10. Ensure motor bearings are not dry. 11. Check sump temperature. Standard preventive maintenance. Cooling towers. Serial number. Frequency. To check. Action. 1. Frequency, weekly. To check, bacterial growth. Action, to rectify by water treatment expert. 2. Frequency, monthly. To check. A. Check leakage in basin. Action. To rectify by cooling tower manufacturer. B. Check all valves for smooth operation. Action. Descale all valves and lubricate. C. Check for abnormal sound and vibrations. Action. Check the motor, fan, belt. D. Inspect louvers, drift eliminators, basin thrash screen for debris. Action. Remove debris. E. Check buildup of debris on the floor of the basin. Action. Remove the debris and clean the floor of the basin. 3. Frequency. Every 3 months. To check. A. Check lubrication of bearings. Action. Lubricate. 4. Frequency. Every 6 months. To check. A. Check float seal. Action. Replace if required. B. Check inlet valve stem. Action. Grease inlet valve stem. C. Clean and disinfect cooling tower. Action. Clean and disinfect the cooling tower with biocides. D. Check structural bolts. Tighten the bolts if required. Standard preventive maintenance. Packaged plants. Serial number. Frequency. Checks, observations. 1. Monthly. Check starter contacts for cleanness. Check electrical connections for tightness and discoloration. Check noise and vibrations. Check filters for cleanliness. Check V-belts. Check motor amps. RYB. Check pulley alignment. Check control operation and safety cutout and note down settings. Check leakage of refrigerant. Clean cooling coil with water. Drain and clean cooling tower sump, clean air-cooled condenser. Engineer, technician, name. Date, signature. Remarks. 2. Bi-monthly. Check electrical connections for tightness and discoloration. Check noise and vibrations. Check filters for cleanliness. Check V-belts. Motor amps. R, Y, B. Check pulley alignment. Check control operation and safety cutout and note down the settings. Check leakage of refrigerant. Clean cooling coil with water. Clean all electrical contacts. Lubricate motor bearings, pumps, cooling tower fans, condenser fans. Drain and clean cooling tower sump, fills and nozzles with chemical. Clean water line strainers of condenser water circuit. Clean air-cooled condenser with water, chemical. Engineer, technician, name. Date, signature. Remarks. Serial number 2. Frequency. Bi-monthly continued. Condenser air water temperature. In. Degree C, degree F. Condenser air, water temperature. Out. Degree C, degree F. Condenser water pressure. In. PSIG. Condenser water pressure. Out. PSIG. Volts RY, YB, BR. Total amps. Of unit R, Y, B. Unit, 1, LHS. Suction pressure, PSIG. Discharge pressure, PSIG. Amps. R, Y, B. OLR setting. Unit, 2, middle. Suction pressure, PSIG. Discharge pressure, PSIG. Amps. R, Y, B. OLR setting. Unit, 3, RHS. Suction pressure, PSIG. Discharge pressure PSIG. Amps R, Y, B. OLR setting. Serial number 3. Frequency. Yearly. Lubricate motor bearings, pumps, cooling tower fans, condenser fans. Descale condenser, clean air-cooled condenser. Clean cooling tower sump, fills and nozzles with chemical. Clean cooling coil with chemical. Clean all electrical contacts. Tighten V-belts. Check, tighten or replace pump gland packing. Engineer, technician name. Date, signature. Remarks. Standard preventive maintenance AC plants, with reciprocating, scroll and screw chillers. Serial number. A. Frequency. Monthly. Checks, observations. Oil level. Oil pressure, PSIG. Compressor discharge pressure, PSIG. Compressor suction pressure, PSIG. CDS water temperature, in, degree C, degree F. CDS water temperature, out, degree C, degree F. CH water temperature, in, degree C, degree F. CH water temperature, out, degree C, degree F. CDS water pressure, in, PSIG. CDS water pressure, out, PSIG. CH water pressure, in, PSIG. CH water pressure, out, PSIG. Motor amps. R, Y, B. Voltage. RY. YB. BR. Check starter and control panel for tightness of all electrical connections and disconnection of contacts. Check joints for leaks. Engineer, technician, name. Date, signature. Remarks. Serial number. B. Frequency. Quarterly. Checks, observations. Check control operation, HP, LP, OP, flow switch. Check and clean air passage of motor winding with nitrogen if required. Lubricate motor bearings. Check crankcase heater. Clean water line strainers of condenser water circuit. Engineer, technician name. Date, signature. Remarks. Serial number. C. Frequency. 6 monthly. Checks, observations. Inspect of filter cartridge. Check oil pump. Check condition and alignment of compressor drive. Engineer, technician name. Date, signature. Remarks. Serial number. D. Frequency. Yearly. Checks, observations. Change oil. Descale condenser and chiller tubes, if required. Lubricate motor bearings. Check megar readings. Clean and check all valves. Pressure test the system. Engineer, technician name. Date, signature. Remarks. Evacuation process. Note cylinder valve V4 will remain closed throughout the evacuation process. Step 1. Open V1 straight ball valve. Step 2. Open V2 compound gauge valve. Step 3. Open V3 discharge gauge valve. Step 4. Open SV suction service valve using an Allen key. Step 5. Start vacuum pump. Note the micron gauge readings. When the vacuum reaches 500 microns, close the discharge gauge valve V3, and stop the vacuum pump. Vacuum will begin to rise. If it does not exceed 1500 microns, it means that there is no leak. The vacuum process is complete. Step 6. Close straight ball valve V1. Refrigerant charging process. Ensure that valve V1 and V3 are closed throughout the process. Step 1. Note the weight of the refrigerant cylinder on the weighing scale, 5,000 grams. Step 2. Open V4 refrigerant cylinder valve. Refrigerant will begin to enter the AC unit through valves V2 and SV. See the level of the refrigerant drop in the cylinder. Step 3. When the compound gauge reads 100 psig, start the AC unit. Step 4. Regulate the flow of the refrigerant from valve V2. Note the weight of refrigerant cylinder, 4,200 grams. The difference of the weights of the cylinder indicates the weight of refrigerant that has entered the AC unit, 800 grams. Step 5. When the desired quantity of refrigerant has entered, close V4 and V2. Run the AC for about 60 minutes. Check suction pressure, amperes, RA, and SA temperatures. If delta T is equal to or greater than 10 degrees centigrade, then the refrigerant charging process is complete. Thank you for being a part of this learning process. For trainings and skilling in HVAC, contact us at info@scholenberg.com. For unmatched worldwide learning experience. All animations and drawings are made by Scholenberg. View our courses on https://sbgblv.com. Thank you.